Right. So first of all, our discussion will start with linked list. What are linked list? How do they work, and so on and so on. Okay, just try to ignore my writing if it's not good. So you have linked lists, right? How do linked lists basically work? Well, I'll explain this in detail. First of all, you have this starting point, starting node. Okay, this will point to a node. The node that will consist of a data. Okay, for example, 20, any data. It could be any data, and this will be the address. Okay, the address of this node. So you will have an address over here. This will point to the next node. This will point to the next node. And this will go on. At the end, obviously what you will have is the null, okay, which is represented through this. So you have is a null end. So you obviously in all these, who's waiting? So in all of these, you will have some sort of data and you will have it as an address. So data and address. So this is what a linked list is. The way we define a linked list basically is, you can keep on making your notes. So basically a linked list frankly, I should type in Word, frankly speaking, is a linear data structure where data is stored sorry, not stored, data is linked with each other by the help of address. So the addresses that you have in every node will help the linked list to be created. Okay, I will come back to this, but I think so instead of spending so much time, what I can do is I can simply show you, because the way linked list has been explained in the book are quite relevant and we can use them. Am I recording the lecture? Yeah, I am. So here we are, we have linked lists over here, and I can explain through this way. So this is your linked list. We have a node, we have a null pointer at the end, we have start pointer. So we have this as a start pointer, we have a null pointer at the end. So that's your node, okay? So the conceptual diagram of adding, if you want to add a new node to the beginning of the linked list. Let's say you have a node and you want to add it in the beginning. So obviously what you will do is the start pointer will not point any longer to this. It will point to the new node. It will point to this. And the address of the new node will further point to this particular node. So that's how you can add it in the beginning. So this will obviously become, it will be there between the start pointer and this one. The conceptual diagram for adding a new node at the end of the linked list. In case if you want to add a new node at the end of the linked list, what you will do is the last node that you have, okay, not the null pointer, this will point to the new, and this is how you will have the new generated, okay, right? And the null pointer will now be here in the new node that has been added. So null will not be here anymore. It will shift to this one. That's how you can add one. If you need to delete the first node in the linked list, how do we make a conceptual diagram of that? Well, what you do is, obviously, you will have the start pointer, and the start pointer will now point to the next node, okay, to the uh, second node that you have, not the first one. And in this case, you can delete this one. So since now this is pointing to this one, this can be deleted. That's how you delete it. How can you delete the last node of the linked list? Well, very simple. You just need to eliminate the pointer that is pointing to the last node. And the null pointer that you had over here will be shifted to the node that is previously over there so that you can delete this one. Very well explained in the book, so that's why I didn't have to waste time and redraw it again. There was no point. A conceptual diagram for adding a new node. So if you want to add a new node into the linked list, anywhere in between, actually what they're saying is anywhere in between, anywhere. So obviously what you'll do is the pointer, this pointer will point to the new node, and the address of this will point to this, and this could be eliminated. That's how you can add one. Right. Why are they leaving and coming back anyway? Okay. Conceptual diagram of deleting the node. Deleting a node within a linked list, which means somewhere in the middle. So obviously, let's say you want to delete is this one. Okay. So you will have this node which will point to the next node. Okay. Leaving this in between, and this pointer will be eliminated. That's how you can delete one. So this is the way your nodes basically work. You can add, delete, and all that. Right. Okay. Now, there's another representation that I will show you with. It will be much more clear to you. For example, I have a data which is, let's say, I can have is, it's Lagos. It's a city in Nigeria. Okay. I've been there many times, that's why. So let's say I have the following addresses. I'll write down the addresses. I'll have the data. And I have, let's say, the link. I will explain this in a tabular form. So let's say I have is 1, 2, 3, 4, 5, 6, 7, 8. And we can simply right. So let's say I have over here is 1, 2, 3, 4, 5, 6, 7, 8, right? So these are the addresses that I have. And let's say, how do I display it back? So let's say I have the following data, and the one location I have over here is A. Okay, and I can say third location I have is S. I can say the fourth location I have is G, and then I could say seventh location I have is L, and in the eighth location I have O. Right. So, which you could do. So I will delete it. So link, let's say link, we'll have some links over here. So if I want to write Lagos, what I'll do is I'll link this one by one. So L, the L will point to 1, and then this will point to LA, this will point to, I'll just explain, this will point to 4, and then G is over here, it's 8, and then we'll have is 3 here. So 4, 8, 1, and 3, and at the end, obviously, S comes at the end. So this will be just the null. This will be the null. Right. So what's happening over here is, as you can see, is my starting is L. So I have L over here. I have L over here. So the link of L is the address 1. So link 1 goes to address 1, and what do I have over here is A. So I write A over here. Okay. Now the link of the data, this is the data and this is the link. So 4 basically is pointing to the address, this one, G. Okay, so I get G here. And G has a further link of 8, which is O. As you can see from here, 8 is pointing to O. And at the end, O is pointing to third one. And the third one is this one, which is S. But S is not pointing anywhere because S at the end has a null pointer. So this is another tabular explanation of how it works. If you can have a conceptual diagram and you can have it both ways. Yes, beta?
Sir, do we have to code this in Python?
No, we don't have to do this. We will be doing this in P4. Not right now. Even the pseudocode of this is not there right now. So we're not discussing it right now. Okay? So
Sorry, sir.
but I can't hear you. I'm sorry, can you repeat again?
Yeah, please.
Aisha, is my internet slow or you're slow? Please, you have to repeat again because I just could not hear what you're saying.
I'm saying that can you repeat the process again, like this one data and link?
Yeah, okay, right. So basically what's happening over here is I just said that these are the addresses, okay? Let's say these are the addresses that you have, okay? And this is the data that you have. Why is it not running? And this is the link that you have, okay? So if in the exam they give you such a kind of tabular diagram, why is it just pointing like this? A tabular. So all you need to do is, I'll not move the mouse. This will be provided to you, just have to display the output. So A has the link 4, and you need to know this link 4 will be 4 basically is the address that this A is pointing to what address? It's pointing to 4, and 4 basically holds what? G. G is a node that has its own link that is pointing to a further address, which is 8. And 8 has this. So it's linked list. It keeps on connecting every node with its address to a link. So one node has a link that points to the address. The other one has its link that points to the address, and this keeps on going on. And obviously, it goes in a sequential manner. And at the end, what happens is you have is a null value, null node that does not further point to any other. Yes. जी बोलो
सर ये सूडो कोड में इस्तेमाल होगा?
जी बिल्कुल सूडो कोड में इस्तेमाल होगा, मगर हम इसको P4 में डिस्कस करेंगे तो होगा।
सर आपको शुरू में ए नहीं आना चाहिए, L A है, मुझे कोई चीज समझ के नहीं आएगी।
क्या बेटा?
अगर हमारा फर्स्ट लेटर ए है तो शुरू में ए नहीं आना चाहिए, हमारा फर्स्ट लेटर एल।
नहीं, देखो इस ऑर्डर में हम नहीं जा रहे, ये रैंडम एड्रेसेस मैंने लिखे हैं, ओके। ये मैंने खुद डिफाइन किया है कि the starting position of this is the starting position. I've defined it myself. Okay, these are just
क्वेश्चन मिलेगा तो हमें डिफाइंड होगा, ये
डिफाइंड होगा। जी एग्जैक्टली डिफाइंड होगा आपको।
ओके, थैंक यू।
तो वेडनेसडे क्लास में इनफैक्ट आई विल टेक आउट सम पास्ट पेपर जिसमें क्वेश्चंस आए होंगे, तो वी विल ट्राई टू डिस्कस ऑल द पेपर्स जिनमें ये आपको क्वेश्चन आए होगा, वी विल डिस्कस दैट। आज हम इसको डिस्कस कर लेंगे। बेसिकली ऑब्वियसली व्हाट वी डिस्कस्ड ओवर हियर,
सर डेटा कुछ भी हो सकता है।
डेटा कुछ भी हो सकता है, एग्जैक्टली।
सर डेटा लाइक
data can have any character. It could also be text, numeric, floating point, कुछ भी हो सकता है डेटा को। Data is simply data. So link
सर इंटीजर भी हो सकते हैं।
क्या हो सकते हैं? इंटीजर भी हो सकते हैं, यस इंटीजर भी हो सकते हैं।
लेकिन सर इंटीजर्स की कैलकुलेशन तो नहीं हो पाएगी।
नहीं, कैलकुलेशंस में होती है मगर वो हम नहीं करेंगे, वी आर नॉट डूइंग दैट। होती है फर्दर, वो आप जब यूनिवर्सिटी में जाओगे तब आप पढ़ोगे इसकी लिंक लिस्ट को, हाउ कैन वी यूज देम। So basically every item that you have, as you can see over here, वो कह रहा है कि linked list is stored together with a pointer to the next item, okay, जिसको हम node भी कहते हैं, it's known as a node, and the last item जो हमारे पास होती है, it has basically a null pointer. Okay, so this is how the structure of a linked list basically works. Most importantly, it's important for you to remember the conceptual diagram in the book, where they have told you how to add, delete different nodes that you have. Okay. इसी के साथ we have another topic इसके साथ ही जो which is connected to it. Where's the new? Come on, read the new page. There it is. So next that we have is basically stacks and queues. Okay. मैं पहले दोनों को explain कर देता हूँ कि stacks basically use होते हैं in memory location. पहली बात ये, if you have stack, I'm talking about stack, and then we have is basically queue. Okay. So जो queue आपके होते हैं, so queue, obviously from the word queue you can tell the application of queue you can find in the process of spooling. What is spooling? Printer में आपने देखा होगा कि queue is created, which means what happens is that when you send a printout, you have is sequence में जो सा आएगा वो सा treat होता जाएगा, right? Stack is mostly used in memory location, like I said. For example, मैं आपको इसको represent करके दिखा देता हूँ. This is your stack, and in stack, let's say you're following. I don't really have to draw this, but let's say I have the following. Let's say I have 60. I have 10, 35, 20, and 7, right? And these are your, so 1, 2, 3, 4, 5, 6, 7, 8. Well, stack is just like as if you pile up the plates. आप plates को से pile up करते हो. You put one plate, the other plate, you pile them up. You put the books. We call this stack. And obviously, if you want to reach this one, you have to pop this out first. You have to pop this out. You have to pop this out. You have to pop this out. And if you want to put something, उसको हम कहते हैं push. You need to put, like if you have only 3, you want to push the 4th one, you will push it in for the 4th one. Then you'll push another one. Then you push another one. So there are two terminologies that we are using in stack, which is pop and push. Pop and push का मैं आपको pseudo code लिख कर दिखा दूंगा. You should have an idea of that. So that's your stack. इसमें we can pop up an item and we can afterwards push another item over here. As far as the queues are concerned, this is what queues are. It's quite the same way, but queues, what we have is this. Let's say this 60, 10, 7. अच्छा, इसमें we will call basically this is the end pointer. Okay, we call this the front pointer. We call this the front pointer in queues. Or इसमें basically we name this as, we use the word base in case of stack. We call this the base pointer. Because base का मतलब है base पे है ना, सबसे base पे सबसे नीचे क्या चीज पड़ेगी, we call this the base. Okay, और obviously जो चीज top पे पड़ी होगी उसको हम कहते हैं this one as the top pointer. So that's the top pointer, that's the base pointer, that's the end pointer, and that's the your front pointer. Okay, that's your queue that you have. और queue में obviously होता क्या है? There are two rules. Last in, first out, first in, first out. तो first in, first out किस पे apply होगा? उस वक्त
Q
first in, first out.
on Q.
Explain करोगी? Can you explain how? Can you explain how? Q में basically क्या है?
Bec-
ठीक कह रही हो आप, सेम किसे कह रही हो? Printer as well. You send a print command, तो obviously ये one by पहले ये आया, फिर ये आया, फिर ये आया, फिर ये आया, फिर आया. So अगर ये पहले आएगा, what is this? So obviously this will go out, then this will go out, then this will go out. Yes. So last in, first out will be where, Amna? Last in, first out. In a stack. Was this not the last thing? Last in, and if you want to take it out, this will be the first out. So whatever comes at the end is the one that goes out as well. So stacks will basically used is the last in, first out, and queues on the other hand will use is the first in, first out rule, the FIFO rule and the LIFO rule. Is that clear?
सर इसमें से कोई ऐसा नहीं है ना जिसके हम बीच के अंदर से निकाल सकें?
नहीं किसी स्टैक के अंदर नहीं, स्टैक के अंदर बीच के अंदर से हम निकाल सकते हैं, हमें एक सीक्वेंस में जाना पड़ेगा.
ओके.
मतलब मैं ये कह रहा हूँ
सर ये नहीं समझ आई.
मैं वही explain कर रहा हूँ. Just a second. Let me explain this again. So let's talk about stack operations. So let's say, just give me some time, let's go draw column properly. Untitled diagram doesn't work. So let's say I have some data over here, 28, then I have over here is 30, then I have is 11, and I have 4. So I have over here is 1, 2, 3, 4, 5, 6, 7. 7 data item stack my pass. So we obviously this is your top pointer, this is your base pointer. Okay. Now let's say Amna beta, you are trying to do what is you are trying to pop something out. Okay, so let's say you have to stack after let's say you remove something. So let's say I have this, I have 28, I don't have to draw the lines, then I have 30, and then I have is 11, and let's say I take out the 4, the top. Okay, so this is the way it will be now. Okay, so 4 has been removed. So 4 has been removed. So the representation of this will be like this, and now this will be your top. And the same manner, let's say you want to insert something. When you want to insert something, you will have is 28, let's say, then you'll have is 30, then you'll have is 11, and then let's say you have is 18. So this is the structure that you will have a stack when it is after 18 has been pushed. 18 has been pushed. When 4 is removed, or you can say 4 has been popped. The both words can be used. Is it clear now? Amna, can you hear me now?
Yes, sir.
Okay. मैं इधर नहीं टाइप कर सकता, मैं ऐसे मैं करना sudo code. Just give me a second, I'll type it in.
Sir,
Yes, beta. Yes, beta.
बीच से आपने 4 हटाया है और उसके बाद 18 को पुश किया है, तो वो 4 कहाँ गए?
वही तो मैं I didn't save it. यही तो मैं बता रहा था कि जब 4 को नहीं, वो मैंने सेपरेट बताया है, मैंने आपको सेपरेटली बताया है कि व्हेन यू रिमूव 4, तो देन आफ्टरवर्ड्स व्हाट डू यू हैव, यू हैव 28, 30 एंड 10 11, और फिर जब हमें इसको मैंने इसको पुश करना होता है, हाउ डू यू डू इट, यू पुट एट द टॉप, इट्स सिंपल एक्सप्लेनेशन। वो इन केस ऑफ पॉपिंग यू जस्ट एलिमिनेट इट, यू डिलीट इट, यू रिमूव इट, सो यू नॉट कंसर्न वो कहाँ गया, बस चला गया, वो टॉप से जाएगा टॉप पे आएगा।
सर नहीं तो हम लोगों को 4 रिमूव करना जरूरी है 18 ऐड करने के लिए?
नहीं 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 नहीं, मैं ये नहीं कह रहा, मैं सिर्फ कह रहा हूं कि इन केस व्हेन यू रिमूव समथिंग हाउ द डेटा स्ट्रक्चर विल लुक लाइक, एंड व्हेन यू ऐड समथिंग हाउ विल इट लुक लाइक, वो तो डिपेंड करता है क्वेश्चन। आपको रिमूव नहीं करना, बिल्कुल नहीं करना। मैं जो आपकी अरे की लेंथ होगी, मैं भी आपको बता देता हूँ, जो अरे की लेंथ होगी स्टैक की 1 to 10 होगी, 1 to 20 होगी, उस पर डिपेंड करता है ना। अगर 20 आइटम्स को होल्ड कर सकते हैं तो फाइन, तो फिर आपको क्या करना पड़ेगा, 20 को में आपको कुछ ऐड करना है तो आपको 20th को रिमूव करना पड़ेगा, फिर ऐड करना पड़ेगा, इन दैट केस। बट इफ यू हैव सफिशिएंट स्पेस देन यू डोंट नीड टू डू इट। आई होप यू गॉट माय पॉइंट।
यस सर।
मैं इसका सूडो कोड लिखता हूँ, आपको इसकी समझ काफी हद तक आ जाएगी। Let's type the pseudo code of this. Okay, just give me a second. So let me just put my somewhere else. To basically, let's write the pseudo code to, let's say, to push an item file का उसका pseudo code कर लेते हैं. So we'll have over here is declare stack array define करेंगे, okay, and let's say I can have it from 1 till 10 जिससे मैंने कहा था, and we can have over here is of integer define कर रहे हैं इसके बाद, and then we'll have obviously declare, we have to declare is the top pointer, which will be, this is why I wanted to use Skype. अब किसने Skype में नहीं क्रिएट किया, बल्कि मैं आज जैसे करता हूँ, मैं आपको लिंक भेज देता हूँ, आप प्लीज वो लिंक ऐड कर लेना अपने उसमें, लिंक ऑफ माय Skype, so just add it, so ज्यादा आसान रहेगा। Integer, अच्छा, फिर I have to declare top कर दिया, then we have declare is the base pointer, and we can also we have to declare another one, इसको अब कह देते हैं stack full। लिमिट डिफाइन तो करनी है ना कि, so let's write how to push it into a stack. So we can say is if the, अब हमने बताया ना स्टैक फुल है कि नहीं है, मैंने डिक्लेयर करा वेरिएबल इंटीजर का कि स्टैक फुल है। I'll just show you, okay, let's say,
फिर बुलियन नहीं होना चाहिए
हाँ,
सर, उसको बुलियन नहीं होना चाहिए।
मैम इंटीजर भी डिफाइन कर सकते हैं, बूलियन डिफाइन सकते हैं, इसमें हम वी कैन इवन डिफाइन इज डिक्लेयर, हाँ बिल्कुल बूलियन भी हो सकता है, और हम इसको ये भी कर सकते हैं कि इसमें हम फ्लैग भी यूज कर सकते हैं। यू नो व्हाट अ फ्लैग इज, रिमेंबर?
जी सर।
We can also use a flag, we can use a boolean, और जो मैं इंटीजर में कह रहा था उसका रिडंडेंसी हो जाएगा। इंटीजर में हम ये कर सकते हैं, we can define is कि यहाँ तक आएगा तो stack is full, okay, so in this particular case we can make it a boolean, right? So क्या करेंगे कि help me out, if हम कह देंगे top pointer is less than stack full, top pointer मतलब stack full जिसकी maximum limit है ना, stack full हो गया ना, if the top pointer is less than stack full, तो फिर हम क्या करेंगे, then we can say is top pointer Last one. Pointer. Have a look and I want you to tell me कि मैं क्या कर रहा हूँ. Let's see the item है. Yes, what am I doing here? Amna? Is Amna here?
Yes, sir.
Yeah. Aisha, you also have a look, please. Have a look at the source to बताओ मैं क्या किया इधर. What is the pseudocode doing? Yes, who can tell me?
स्टैक फुल है, अगर स्टैक फुल नहीं है तो वो उधर कुछ ऐड कर देगा, कोई आइटम ऐड कर देगा, लेकिन अगर फुल है तो वो आउटपुट दे देगा कि स्टैक इज फुल।
Exactly. So the pointer है उसमें हम ऐड कर सकते हैं. We can add another. Okay. और जो भी item है that will go in the stack top pointer में. Else we can have a stack as full. There could be another way we can write this as well, but this is one of the easiest way I could write it.
सर अगर हमारा स्टैक फुल बुलियन है तो हम टॉप पॉइंटर स्मॉलर देन कैसे लिख सकते हैं?
Sorry.
सर अगर हमारा टॉप पॉइंटर मतलब वो इंटीजर और स्टैक फुल जो है वो बुलियन है, फिर तो उसमें यस और नो आएगा, उसको स्मॉलर देन कैसे लिख सकते हैं?
इसलिए मैंने उसको इंटीजर किया था. बूलियन का भी हम कर सकते हैं, इसलिए मैंने इंटीजर यूज किया था. इन केस ऑफ बूलियन हम उसको चेंज करेंगे. निशा, व्हाट यू आर सेइंग? मैंने इसलिए इनिशियली इंटीजर यूज किया था इधर, बट शी इज आल्सो राइट. हम बूलियन से भी कर सकते हैं, हम फ्लैग से भी इसको कर सकते हैं.
तो सर हम उसको भी क्यों नहीं इंटीजर करें, यानी कि अगर हम सारे को इंटीजर कर दें,
इसको
ऑल थ्री, तीनों को, टॉप एंड स्टैक फुल को.
तो इंटीजर किया होगा बेटा. अच्छा वैसे आपको तो इसका सूडो कोड आपको P2 में नहीं पूछा जाएगा, तो मैं डिस्कस कर रहा हूँ. We will discuss this further in detail. They will not ask you this in P2. जनरल आइडिया दो, ये तो हो गया. I'll give you some time. Tell me किसका करेंगे हम. If we want to pop an item, उसका क्या, उसमें here what can we do? What changes will there be if you want to pop out an item from the stack? मैं वैसे ही डिस्कस कर रहा हूँ आप लोग से कि आपको फ्यूचर में आइडिया हो जाएगा. मैं एक रफ सा ड्रॉ कर देता हूँ. आई लीव दिस लाइक यस, कोई रफ आइडिया, जस्ट गिव मी रफ आइडिया.
फर्स्ट हम चेक करेंगे कि स्टैक फुल है या नहीं. अगर वो फुल है तो हम नहीं कर सकते, अगर वो फुल नहीं है तो हम ऐसे ही कर सकते हैं, लेकिन अगर वो फुल है तो हमें एक आइटम एमिट आउट करना पड़ेगा.
ठीक है, ठीक है, ठीक है, ठीक है. निशा, एनी आइडिया? How can we check how to pop out an item from the? चलो anyway, शुरू करो, हम भी फिर डिस्कस कर लेंगे. It's okay. इसमें नहीं डिस्कशन तो why should I confuse you with this?
तो हम अरे के थ्रू नहीं कर सकते.
अरे को क्या बेटा?
सर मतलब आपने टॉप पॉइंटर लिखा है, टॉप पॉइंटर में जो वैल्यू हो तो उसी की इंडेक्स नंबर को हम इनपुट करें, उसी पे आइटम डाल दें, जो भी नंबर है उसको रिप्लेस कर दें।
अच्छा मैं लिख देता हूँ, आई डोंट नो आपको समझ आएगा कि लिख देता हूँ, वी विल ट्राई। वी कैन से इज आप जो कह रहे वी कैन हैव द टॉप पॉइंटर if it's equal to base pointer -1, okay, अगर ये है तो we can say is then output कर दे stack is empty, else else हम कर देंगे जो भी आइटम है I'll give you time, think over it, मैंने क्या लिखा है। Top okay, so this was to pop out an item, yeah, please take your time और सोचो मैंने क्या लिखा है। अगर स्टैक के अंदर कोई चीज ही नहीं है तो हम पॉप आउट तो कर ही नहीं सकते ना, इट हैज टू कंटेन समथिंग, पहली बात तो ये है। हाउ कैन वी पॉप आउट समथिंग फ्रॉम एन एम्प्टी स्टैक, दैट्स नॉट पॉसिबल।